Hello everyone, so today I will be showing you what I've been working on for the past few weeks. Right in front of you, you have a mini robot based on a Raspberry Pi system and the TC001 thermal camera. The purpose of this is I wanted to try and develop a program which is able to track warm objects and constantly show them on the screen. So imagine you have a deer walking across a field. I wanted something so that I can have the thermal camera mounted on top of a roof or a tall object that will automatically track and follow an animal. So what I realized I needed was I needed to build a robot with movement. As you can see, the robot in front of you has two servos. Each servo has a weight rating of 20 kilograms. We have one down here and one up here. This enables the robot to move in 2 degrees of freedom. As you can see, the camera can be rotated down and up, and it can be also rotated horizontally, left and right. The way I've built this was so that the Raspberry Pi, which is built into this case, is able to move along with the whole of the top of the robot. This just helps me maintain no stress on the cables or anything mounted on top of the robot. The Raspberry Pi comes built within this case. This case has an inbuilt fan at the bottom, which is basically constantly spinning because it does get quite warm when the program is running. This program is built so that when the Raspberry Pi gets power, it automatically turns on. It identifies what thermal camera from Topdon is connected, and it identifies the servos and starts a Wi-Fi hotspot. This Wi-Fi hotspot is then accessible through my graphical user interface, which I'll show you in just a bit. Other than that, I can show you the cable managing. So from the thermal TC001, we have the USB-C cable, which is provided within the box of the product. This plugs into the rear of the Raspberry Pi to the USB-C 3.0 port. Coming from within the Raspberry Pi case, connected to the PCA servo shield, I've got 2 cables, one running to the top servo and one running into the base servo. This allows me to control it horizontally and vertically. And then I've got one cable here which runs from the laser into a MOSFET. Originally this laser was built with a pressure plate. This pressure plate, once clicked, the laser would turn on. So I had to rewire this and connect it to the MOSFET. Now the MOSFET is able to directly control the laser, turn it on and off when I press a button on the graphical user interface. So as you can see, the laser's off. When I press the button, the laser turns off. I will turn it off and on again. So that's basically the basics of what I have built so far. A few of the technicalities that I struggled with when making this robot stemmed from the Raspberry Pi. I wanted to make it as neat as possible and tried to make everything fit within this one Raspberry Pi case. The problem was there's quite a few things that I had to fit in here. While having all the connectors and adapters inside, it all started taking a lot of space, and it just took a while to make everything fit. So if you are going to make something like this, just beware you're going to need a rather big case. So when you look inside, it's quite a mess. What you can see at the very top, you have a USB-C cable to a DC connector. This cable is the USB-C cable right here. This plugs in directly into the back of the servo power bank. This provides power to the servos to make them move. Just below here, you might be able to see it, you have the PCA servo shield. This tells the servos what to do and how to move. So the power directly comes from the connector that I'm holding right here. Just above this, we have the actual Raspberry Pi stuck to the top of the case, held in with a few plastic screws I can see. And then we have the connector to the laser. This runs through to deep inside at the back of the case. I can't even see it myself right now, but there is a MOSFET. This MOSFET is in charge of basically it's a switch that runs off of a PWM signal. So using the Raspberry Pi, you can activate and deactivate the current to run through this wire to turn the laser on and off. So this whole Raspberry Pi and thermal camera project has been based on this single robot. To just demonstrate, you can see how this servo is able to move up and down. Currently it is only able to rotate 90 degrees. I haven't been able to change this within the program, but that's all it can do right now. And the exact same with this bottom servo. It can rotate 90 degrees, however they are 270 degrees functionable. So later on I will be able to make it virtually turn all the way around, so I will be able to scan a lot more surroundings around where this will be set up. So now I'm just going to quickly show you how the whole of the Raspberry Pi connects with my computer and how all the information and data gets transferred. To make everything work, I have programmed into the Raspberry Pi a hotspot. So the second the Raspberry Pi turns on, a hotspot is turned on. This allows me to SSH into the Raspberry Pi. That's basically a quick term for remote controlling into the Raspberry Pi. So here we've got a command prompt. We can just sign into the Raspberry Pi. So now we're establishing a connection, and I can type in my password. So right here, it just means that I've managed to successfully connect to the Raspberry Pi. Here we can see that I'm in my main directory. So if I check what I have around here, I've got a boot log, which just tells me whether my Raspberry Pi is booted correctly, captive portal. Within my project, you can see I've got a few programs. The main ones we're going to focus on is camera stream, hardware controller, and hardware server. These are all Python programs which run on the Raspberry Pi. So if we go to camera stream, you can see I'm importing a few things: socket threading, CV2, and NumPy. Right here, you can see I have defined the width and the height of the actual video which is being received through the Raspberry Pi, and I am defining what kind of ports I will be transmitting this on the Raspberry Pi, so that I can collect all the video from the Raspberry Pi using the computer. This function basically just goes through, searches the Raspberry Pi through all the USB ports, and it identifies whether there is a Topdon camera connected to it. It's quite a basic function. It's basically just checking whether the camera has the correct resolution, and if not, it will throw the camera away. Next, it basically assigns the files. So next, it basically just processes the frames, identifies. So next, it basically just processes the frames. It turns them into PNGs ready for transmission. And then I broadcast this using the host and the port address. And then once everything gets connected and the client accepts the transmission, the broadcasting can start, and the video will be sent to my PC. Next, we're going to have a look at hardware controller. So here we again import a few things. The basics here are we are identifying what kind of board I am using. So I am using a PCA 9685, which is written right here. This is a function which basically communicates with the servo shield. This delivers power to the servo and tells him how far it has to rotate left or right or up or down. I've defined which servo channels I'm using within the shield, and right here, this is basically calculating how far I need to move the servo each time. And then I also have a set laser function. This allows me to remotely turn the laser on and off using my graphical user interface as well. And then finally, we have the hardware server. So here, basically what we do is we communicate with the computer and relay the information to the previous program I just showed you, the hardware controller. So we're communicating with the hardware controller here, and we're importing the move servo and set laser functions. And in this program, we connect to another port, 5050, to the Raspberry Pi. This is all ran still on the Raspberry Pi hotspot. We connect to the computer and we listen to what the computer is sending, whether it wants the Raspberry Pi to move the servos around or whether to turn the laser on and off. And at the bottom we just start the server, so this automatically starts running when the Raspberry Pi turns on. So now I'm going to quickly show you the graphical user interface. You might recognize it from previous programs or posts that I have made regarding the Topdon thermal cameras. So on the left you have quite a simple settings bar. You can connect to the camera, record, take a picture, adjust the color profiles. Right now I'm going to quickly connect to the camera. Right, so it only turned on because I'm connected to the hotspot already of the Raspberry Pi. So we can quickly change the color profiles. For now I'm just going to keep it as bone. I think it's quite simple to understand what everything is. Adjust the brightness, contrast, blur radius. I don't use this ever. It really makes everything blurry. However, if someone ever finds a need to use it, it's there. Rotation, it rotates the camera 90, 180 and 270 degrees. Right now I don't have to do that because it's just oriented the right way on the stand. I can invert the color map, so I can basically flip everything around. So right here, everything that is white is warm. If I invert it, everything now that is dark is warm, and everything that is bright is cool. Here we've got thresholds, but for today I'm not going to be using them. And overlap threshold, I'm also not going to use this for the time being. On the left, we have the servo and the Raspberry Pi settings. Here we've got the COM port. Basically what you have to put in here is the IP address of the thermal camera. I have predefined the Raspberry Pi's hotspot to always be the same IP. So if I click this refresh button, the IP automatically appears in the box and I can click connect. At the bottom it says connected to 10.42.0.1. This is the IP and it just says that I have successfully connected to the Raspberry Pi and everything should be working. So if I move the horizontal sliders, you can see the image is moving around. Well, it's a bit wobbly right now. The Pi is kind of not very stable, however it works. Same with the vertical. I can move the Pi visual down and then up. I have a button here which turns the laser always on. You can't see the laser shine on the video because the thermal camera only sees thermal, which is heat, hot or cold, and the laser, unless it's shone for a very long time at a very dark object, it will not present any heat changes. So I can turn that off for now. Flips the rotation or the direction that the horizontal bar will be moving. So if I move to the left, the flip button, what it does, it orients in which way the tracking function on the thermal camera works. So depending on the orientation the camera is mounted onto the robot, you can adjust it using these two buttons so that it always tracks the camera movement in the right direction. And then you have the center servo button. So if I displace the camera a bit into the wrong directions and I click center servo, it moves everything into the middle, which is 90 and 90 as it goes from 0 to 180 in both axes. And then you have the start tracking button. If I press the start tracking button, the camera will start chasing the hottest point. The hottest point is identified by the red marker, so this center point will move down to the bottom right diagonal direction to try and overlap this red dot. As you can see, the red dot is kind of jumping around right now because it's pointing outside and the outside temperature is around 30 degrees Celsius right now, which is quite warm, and everything around here is the same temperature, so it's trying to pick out the hottest point, but it's struggling. So I'm going to wait until it cools down, and then I'm going to take out a hot water bottle and use it as a marker, and you will be able to see how the thermal camera starts tracking it. So what I did was I filled a glass jar up with really warm water just to get the hottest point out in the surrounding area. So what you can see is I'm currently just waving the pot around and walking around. the camera identifies the hottest point as the actual jar, and as I walk around, my location on the image shifts. The center point then is not aligned with the hottest point, so the program has to figure out how to move the camera so that the cross in the middle overlaps the red dot. So using simple programming, I have been able to set values to each servo. You can see on the right hand side, as I am moving now, the servo bars are also adjusting dynamically. They're either increasing to the right or decreasing to the left. Same with the vertical height. As you can see, there's a green dot on my shirt right now, so that's the laser pointing towards the jar and being turned on because it's hovering over the hot point. The green dot isn't exactly over the jar. I'm not going to worry too much about that because I'm quite far away, and the servos have a big stepping range, so the motors aren't able to precisely angle the camera into the exact direction of the warm jar. So as you can see, I'm walking around, moving my location along with the jar, and the laser is constantly following us and turning on exactly in front of me. So if I would have an animal in the field, I can be sure that the laser will be able to locate them and point in that specific direction. So now I'm just making my way back. I'm going to be walking side to side, holding the jar in front of me. It's not as warm as it used to be, so I might be losing a few heat signatures to the surroundings. So walking side to side, the camera's still following me. You can see on the right hand side in the analysis bar, the laser heading is going from grey to green. When it's grey, it just means that the laser is turned off and it's searching for the hot point. When the hot point is being centralized by the camera and it's right over the top, the heading turns green, which means that the laser has turned on. So I'm getting very close now. Now the laser also has to aim itself further down. However, it marks the point perfectly and turns the laser back on. So that's basically all I've been working on. I will be releasing a video very soon. It's going to be a wildlife investigation out in the fields. I'm hoping to be able to spot some really cool animals and share them with you. But for the time being, thanks for watching, and I hope to see you soon.